When installing a variable frequency drive and the drive terminals are rated at 75 degrees Celsius, and the wire being used is THHN rated at 90 degrees Celsius for the incoming power feed, it is necessary to derate the ampacity of the THHN wire. This is because the drive terminals are rated at 75 degrees Celsius. According to the National Electrical Code, specifically Table 310.15b16, the ampacity of THHN wire is derated for use at temperatures above 75 degrees Celsius and below 90 degrees Celsius. For a 75 degrees Celsius conductor, the ampacity is derated by 15%. Therefore, if THHN wire is being used to power a drive with 75 degrees Celsius rated terminals, the ampacity of the wire needs to be multiplied by 0.85, which is equivalent to 1 minus 15% to determine the allowable current. As an example, if the THHN wire has an ampacity of 100 amps at 90 degrees Celsius, the allowable current for use at 75 degrees Celsius terminals would be 85 amps, calculated as 100 amps multiplied by 0.85. It is important to adhere to this derating rule to ensure that the wire does not overheat, which could potentially lead to a fire or other electrical hazards. The National Electrical Code provides comprehensive guidelines for electrical installations, including requirements for conductor ampacity and temperature ratings. The primary goal of these codes is to ensure electrical safety and prevent hazards such as fires and electrical shock. Ampacity refers to the maximum amount of electrical current, measured in amps, that a conductor can carry continuously without exceeding its temperature rating. The temperature rating of a conductor indicates the maximum temperature in degrees Celsius or Fahrenheit that the conductor's insulation can withstand without degradation. THHN wire is a common type of building wire used in electrical installations. It has a thermoplastic high heat resistant nylon coating, which gives it good resistance to heat, moisture, and abrasion. THHN wire is typically rated for 90 degrees Celsius in dry locations and 75 degrees Celsius in wet locations. Variable frequency drives are electronic devices used to control the speed of alternating current electric motors. They are widely used in industrial and commercial applications to improve energy efficiency and process control. VFD can generate heat, and their terminals are often rated for a specific maximum temperature. When selecting conductors for use with variable frequency drives, it is essential to consider the temperature rating of the drive terminals and the ambient temperature in the installation location. If the conductor's temperature rating is lower than the drive terminal's temperature rating, the conductor's ampacity must be derated to ensure that it does not overheat. Derating is the process of reducing the allowable current carrying capacity of a conductor to account for factors such as high ambient temperatures, multiple conductors in a raceway, or termination points with lower temperature ratings. The National Electrical Code provides tables and formulas for calculating derating factors. In the case of THHN wire used with 75 degrees Celsius rated terminals, the derating factor is 0.85, as specified in NEC Table 310.15b16. This means that the allowable current carrying capacity of the THHN wire must be reduced by 15%. To determine the appropriate size of THHN wire for a specific application, the following steps should be taken. Firstly, determine the load current. This is the amount of current that the variable frequency drive will draw under normal operating conditions. Secondly, select a THHN wire size that has an ampacity equal to or greater than the load current based on its 90 degrees Celsius rating. Thirdly, apply the derating factor of 0.85 to the ampacity of the selected THHN wire size. Fourthly, verify that the derated ampacity of the THHN wire is still equal to or greater than the load current. If not, select a larger THHN wire size and repeat steps 3 and 4. It is important to note that the National Electrical Code also specifies requirements for conductor insulation type, size, and installation methods. These requirements are designed to ensure that electrical systems are installed safely and in accordance with accepted industry practices. In addition to temperature derating, other factors can affect the ampacity of conductors. These factors include the number of conductors in a raceway, the ambient temperature, and the presence of harmonics. When multiple conductors are installed in a raceway, the heat generated by each conductor can raise the temperature inside the raceway, reducing the ampacity of all the conductors. The National Electrical Code provides tables for adjusting the ampacity of conductors based on the number of conductors in a raceway. High ambient temperatures can also reduce the ampacity of conductors. The National Electrical Code provides tables for adjusting the ampacity of conductors based on the ambient temperature. Harmonics are distortions in the alternating current waveform that can increase the current flowing in conductors, even if the load current remains the same. The National Electrical Code requires that conductors be sized to account for the effects of harmonics. When installing electrical systems, it is essential to follow all applicable codes and standards. This includes the National Electrical Code, as well as any local codes and regulations. Proper conductor sizing and derating are critical for ensuring electrical safety and preventing hazards. Ignoring these requirements can lead to overheating, insulation damage, and potentially fires. In summary, when using THHN wire with 90 degrees Celsius insulation for a variable frequency drive with 75 degrees Celsius rated terminals, the wire's ampacity must be derated by 15%. This is to comply with the National Electrical Code and prevent overheating. The derated ampacity of the THHN wire must be equal to or greater than the load current. It is also important to consider other factors that can affect conductor ampacity, such as the number of conductors in a raceway, the ambient temperature, and the presence of harmonics. Following all applicable codes and standards is essential for ensuring electrical safety. When working with electrical systems, it is always best to consult with a qualified electrician. Electricians have the knowledge and experience to ensure that electrical systems are installed safely and in accordance with all applicable codes and regulations. They can also help to identify and correct any potential hazards. Additional considerations may come into play when dealing with specific variable frequency drive installations. It is often beneficial to consult the manufacturer's specifications and recommendations for wiring and termination requirements. Variable frequency drive manufacturers typically provide detailed information on conductor sizing, temperature ratings, and other relevant factors. Some variable frequency drives may have specific requirements for conductor types or termination methods. Following the manufacturer's recommendations can help to ensure proper operation and prevent damage to the drive or other equipment. Furthermore, it is essential to consider the overall environment in which the variable frequency drive is installed. If the drive is located in a hot or humid environment, additional derating may be necessary. The National Electrical Code provides guidelines for adjusting conductor ampacity based on ambient temperature and humidity. Regular inspections and maintenance are also crucial for ensuring the long-term reliability and safety of variable frequency drive installations. Conductors and terminations should be periodically inspected for signs of damage, such as cracking, discoloration, or loose connections. Any damaged component should be replaced promptly. The variable frequency drive itself should also be inspected and maintained according to the manufacturer's recommendations. This may include cleaning, lubricating, and testing various components. By following these best practices, it is possible to ensure that variable frequency drive installations operate safely and efficiently for many years. It is also recommended to keep detailed records of all electrical work performed, including conductor sizing calculations, derating factors, and inspection results. These records can be valuable for troubleshooting and maintenance purposes. In addition to the National Electrical Code, other standards and guidelines may be relevant to variable frequency drive installations. These may include standards from organizations such as the Institute of Electrical and Electronics Engineers, the National Fire Protection Association, and the American National Standards Institute. It is important to be familiar with all applicable standards and guidelines and to follow them carefully. Proper grounding is also essential for electrical safety. Variable frequency drives can generate significant amounts of electrical noise, which can interfere with other equipment. Proper grounding can help to reduce electrical noise and prevent electrical shock hazards. The National Electrical Code provides detailed requirements for grounding electrical systems. These requirements should be followed carefully to ensure that the system is properly grounded. Surge protection is another important consideration for variable frequency drive installations. Variable frequency drives are susceptible to damage from voltage surges caused by lightning strikes or other electrical disturbances. Surge protection devices can help to protect variable frequency drives from damage. These devices should be installed in accordance with the manufacturer's recommendations and all applicable codes and standards. In conclusion, installing a variable frequency drive involves several important considerations, including conductor sizing, derating, grounding, and surge protection. By following all applicable codes and standards, and by consulting with qualified electricians and variable frequency drive manufacturers, it is possible to ensure that variable frequency drive installations are safe, reliable, and efficient. Remember to always prioritize safety when working with electrical systems. If you are not comfortable working with electricity, it is best to hire a qualified electrician. Electricity can be dangerous, and it is important to take all necessary precautions to prevent electrical shock and other hazards. When working with electrical systems, always wear appropriate personal protective equipment, such as safety glasses and insulated gloves. Disconnect power to the circuit before working on it. Use properly insulated tools. Never work on electrical systems in wet or damp conditions. By following these safety precautions, you can help to prevent electrical accidents. And to reiterate the initial point, the need to derate the THHN wire when used with 75 degrees Celsius rated terminals is a critical safety measure mandated by the National Electrical Code. Ignoring this requirement can lead to overheating and potentially dangerous situations. Therefore, always remember to multiply the ampacity of the THHN wire by 0.85 to determine the allowable current when using it with 75 degrees Celsius rated terminals. This simple calculation can help to ensure the safety and reliability of your electrical system.